A million steps to perfection. Sounds pretty intense, right? Well, today we're diving into a groundbreaking paper that suggests a totally new way to think about building ultra-reliable AI. And here's a spoiler. It's not about making them bigger. It's about making them smarter by organizing them in a completely different way.
So think about it for a second. Could you really trust an AI to manage something as massive and complex as a global supply chain? Or to build a skyscraper where every single step has to be perfect? These are monumental tasks that require near-flawless execution, step after step after step. That's really the big question here. Can we ever get an AI to be that reliable?
You know, we see these headlines all the time. New AI model is 99% accurate. And we think, wow, that's incredible. It's basically perfect. And for a single, one-off task, yeah, it is. But what happens when you need that AI to do something 1,000 times or 1,000,000 times in a row? Well, that's where the math starts to get a little bit terrifying.
Because that 99% accuracy means there's still a 1% chance of error. And that tiny error rate compounds. Think of it like dominoes. If you have 100 dominoes, that 1% error rate means you're almost guaranteed to have a failure somewhere along the line. It's not a question of if the chain will break, it's a question of when, and it happens way faster than you'd think.
This problem is so fundamental, the researchers call it the AI scaling wall. It's this massive barrier we keep hitting when we try to get AI to do really long, complex tasks. It's like trying to build a ladder to the moon, where every single rung has a tiny chance of breaking. It doesn't matter how strong the individual rungs are. Eventually, one will fail, and you're never going to make it.
For years, the common wisdom in the field has been to just throw more at the problem, right? Bigger models, more data, more computing power. The idea was that if we just make the AI smarter, it'll eventually stop making these little mistakes. But what if that whole approach is a dead end? What if we've been climbing the wrong ladder this whole time? So, to really put this to the test, the researchers chose the perfect benchmark, the Towers of Hanoi puzzle. It looks deceptively simple, just moving disks around. But the number of steps required to solve it just explodes as you add more disks. With 20 disks, you're looking at over 1 million perfect sequential moves. It is the ultimate stress test for AI reliability.
So how did the best and brightest AI models do? Well, they failed, and they failed catastrophically. We're not talking about getting tired after thousands of steps. They couldn't even make it past a few hundred. This is a huge wake-up call. It proves pretty conclusively that just trying to build a single, smarter AI agent isn't the answer. We need a better system.
So if bigger isn't better, then what's the alternative? This is where the paper proposes a radically different path forward. It's a complete paradigm shift. What if, instead of trying to build one single giant brain, we built a highly organized swarm of much simpler ones? And this slide really nails the difference. The old way, making smarter agents, focuses on a single model. But errors are inevitable, and they become catastrophic over time. It's also super expensive. The new way, building smarter systems, is all about organizing lots of simple agents. The whole system is designed to catch and correct errors at every single step. It's way more efficient and a lot cheaper.
Now, the researchers didn't just dream this up as a theory. They actually built a system that does it. It's a method they call Maker, and it is a total game changer. It's built on 3 really simple but incredibly powerful ideas.
So what's the secret sauce here? It all comes down to these 3 things. First, extreme decomposition. Second, multi-agent voting. And third, red flagging. Let's quickly break down what each of those actually means.
Okay, first up, maximal agentic decomposition. It's a bit of a mouthful, but the idea is pure genius. You take that massive million-step problem and you shatter it into the tiniest possible pieces, over 1 million micro-tasks. Now, each little AI agent only has one super simple job to do. It's like an assembly line for intelligence. But what if one of those little agents makes a mistake? That's where the second step, multi-agent voting, comes in. For every single microtask, you have multiple agents working on it independently. They all propose an answer, and then they literally vote. A decision only gets made if one answer gets a clear majority. It's the same exact principle that makes computer memory so reliable. It's constantly making and correcting tiny errors.
And the third and final layer of protection is red flagging. This is the system's own built-in quality control. It can tell the difference between a good, clean response, which is usually short and concise, and a red-flagged one that looks off. If it's too long, seems confused, or is just formatted weirdly. If it sees a response that's likely to be wrong, it just gets tossed out and the system tries again. So we have this incredible new system with 3 layers of protection built right in. But the million-dollar question, or I guess the million-step question is, does it actually work? Let's take a look.
The results are just staggering. Maker didn't just solve the problem, it absolutely aced it. Over 1 million steps with not a single error. 0. This is a monumental achievement. It is the first time any AI system has ever completed a task of this length and complexity with perfect accuracy.
And here's the real kicker. Not only is it more reliable, it's also way cheaper. You'd assume you should use the most accurate model possible, right? But check out this table. They found that the model with the lowest error rate, O3 Mini, wasn't the most cost-effective. The sweet spot was actually GPT-4.1 Mini, a smaller, cheaper model that was almost as accurate. This is huge. It means we can solve these massive problems with AI that's more accessible than ever.
So what does this all mean? It means we might have been thinking about the path to powerful AI all wrong. The future isn't just about building bigger, smarter agents. It's about building smarter systems.
And this isn't just an academic exercise. This has real-world implications that could change everything. We're talking about reliability that allows us to trust AI with mission-critical tasks. We're talking about efficiency, solving huge problems with smaller, cheaper models. And we're talking about safety. When each agent only has a tiny task, it's so much easier to control and audit the whole system, which seriously reduces the risks.
I think the authors of the paper put it perfectly. They said, by smashing intelligence into a million pieces, it is possible to build AI that is efficient, safe, and reliable. That just sums up the entire idea in a nutshell.
So it really leaves you with a big question, doesn't it? Is the real path to superintelligence not building a single, bigger brain, but creating a better organized swarm? It's a fascinating thought, and this paper suggests it might just be the way forward. I'll leave you with that to think about.